All right, good morning. The bell ringer, describe a Venn diagram using whole numbers less than or equal to 10 separated into odd and even groups. Okay, so we know Venn diagram uses different groups to actually describe the total data involved in the entire selection. So let's look at this carefully. How do you determine which numbers to put in the parts of the Venn diagram? Okay, so which ones are odd and which ones are even? Obviously, from learning from binary numbers that even numbers are numbers that are divisible by 2. So odd numbers are not divisible by 2, and that includes between the whole numbers less than or equal to 10, 1, 3, 5, 7, and 9 are in the odd section. And then on the other side, the even, it's 2, 4, 6, 8, and 10. What about 0? It's a whole number. Does it go in odd? Does it go in even? Does it go in both? Where should it go? Actually, it's neither odd nor even. It would go on the outside. Now, this is this sincere mathematician's speculation. Lots of mathematicians say it's both. Some say because on the number line it falls in the sequence of even, that it's even, but 0 holds no value. So in order for a number to be odd or even, it has to hold value. I am under the impression since 0 is a number that describes no value, it should be outside of this Venn diagram. So let's talk about good things. Anybody have any good things to share? Please reach out to me via email or via the Google Classroom and let me know, and I'll love to add it to the Google Classroom. I promise I will not use your name at all. Good things for me. Last night we finished our second tennis match in Waller, Texas. Really tough fight. Ended up losing the match 12 matches to 11 matches. So it was very close. Anyway, you see the tennis players tell them, good job on trying really hard. So let's move on. Miss Snow conducted a survey of her homeroom students. She asked them what math course and what science course they were taking this semester, and below are the results. What can we say about this Venn diagram? Let's analyze the data and list 5 facts about Miss Snow's homeroom. So one fact we can say, all the numbers in this Venn diagram add up to the total number of students in Miss Snow's classroom. So 14 and 6 is 20, plus 4 and 5, which is 9, is 29. That's the very first piece of information. That's 29 students. How about this? In this intersection right here, that's a group of students that take not only Algebra 2, but also chemistry. Notice it's in the Algebra 2 circle, but it's also inside the chemistry circle. So it's in the intersection, which means it's a student or students that take Algebra 2 and chemistry. Okay? Or both, whatever you want to call it. Now, how about the students out here? They're not in Algebra 2 and they're not in chemistry. So what are we doing? We have 4 students taking both. And there are 6 students taking neither. Notice that the 6 lies outside of any circle. The circle is Algebra 2. Any students inside the circle take Algebra 2. And this is chemistry, and students inside that circle taking chemistry. So the 6 is inside neither, so they are taking neither. 18 students taking Algebra 2. Well, we're saying that out of the 29 students in Miss Snow's classroom, how many are taking Algebra 2? That includes all the students inside the Algebra 2, even the ones that are taking both Algebra 2 and chemistry, because it's just saying how many students are taking Algebra 2. Well, those 4 students are taking it also. So 14 and 4 is 18. The answer is 18. And last but not least, there are 9 students taking chemistry under the same pretenses. All students inside this circle, whether they're taking both or just chemistry, add them together and you get 9. There's a couple other things we can say. How many students are taking either Algebra 2 or chemistry, but not both? That would be 14 plus 5 or 19. How many students are taking Algebra 2, chemistry, or both? that would be 14 plus 4, which is 18, plus 5 is 23. You could say all kinds of things. How many people are taking just Algebra 2 or nothing at all? 14 and 6, that's 20. So knowing that we know this information, now we can answer a few probability questions. If a student is selected at random, what is the probability that a student is taking Algebra 2 and chemistry? Algebra 2 and chemistry, that's in between here. That is easily to understand that the answer is 4. Probability of both is 4. How about the probability of not taking Algebra 2 and chemistry? That's students that are taking neither, and we discussed that. That's this number lying outside of the circle, because anything inside is taking one of the classes. So the probability is 6 out of 29. We know that everything out of 29, because that's the total number of students. What is the probability of randomly selecting a student that's taking Algebra 2 or chemistry? We need to explain our reasoning. So Algebra 2 or chemistry, that's not both, is it? Either they're taking Algebra 2 or they're taking chemistry. Not neither or not both. So it's 14 and 5, and we add those two probabilities together. If you're taking Algebra 2 by itself, it's 14. Or if you're taking chemistry by itself, it's 5. So the probability of Algebra 2 or chemistry is 19 over 29. Find the probability of a student taking chemistry given that the student is not taking Algebra 2. That means just chemistry but not taking Algebra 2. Well, these are taking both. This is the only set of students that are taking just chemistry. So the answer is 5 out of 29. All right, students survey 758 spectators at a national championship tennis match. The survey results indicate the following. 428 are male, or 421 are male, 256 have a two-handed backhand, 176 of the people have a two-handed backhand swing are also female. We need to draw a Venn diagram and label the data. Okay, so I've done that. I've got a circle for the male, I've got a circle for the female, and I got a circle for the 200 backhand. And for ease of this lesson, we will say that male and female are not, they're not intersected. There's not a male and female, and there's not a female and male. For ease of this lesson, we'll say they're mutually exclusive. You need to remember that term. You cannot be female and male, and you cannot be male and female in this particular assignment. So 420 are male, 256 have 200 backhand swing, 176 with a 200 backhand swing are female. So here's some information we know. Of the total 758 spectators, if we subtract the male students from 758, we find that we have 337 female spectators. Then we can take that information and we can subtract the 176 female with a two-handed backhand swing to find the number of survey spectators that have a two-handed backhand swing and are female. Okay. Then we take the information we got from up the data that was given, 256 have a 200 backhand swing, and subtract the information we just got, 176 of the females that have a 200 backhand swing, to find out that 80 of them are male with a 200 backhand swing, and then subtract the 80 from 421 total male spectators, and we find that there are 341 male without a 200 backhand swing. And so the 337 minus 176 give us, well, we know 176 are female with a 200 backhand swing. So that's the intersection there. 161 are female without a 200 backhand swing. That goes there. The 80 that are male with a 200 backhand swing goes in this section right here. And then the 341 that are male without a 200 backhand swing goes here. Now, out of the 758 constituents, we can put that in there. Notice that you can't have any spectator in the middle that are either male or female. Like I said, for ease of this lesson, there are only male and female spectators. All right, what is the probability of a person selected at random from the group is male? Well, let's see. Of the 758 surveyed, 421 are male. So the probability of male is 421 over 758, or 0.555, or 55.5%. What is the probability that a person selected at random from the survey group is female? Well, we already said that 421 are male, therefore 337 are females. Female probability is 337 out of 758. That's 0.445, or 44.5%. What is the probability the person selected at random in the group has a two-handed backhand swing? We have to add the total of the two-handed backhand swing together. 80 plus 176 is 256, but that was given to us already. So all we have to do is put probability of 256 over 758, or 33.8%, 0.338 in decimal form. All right. What is the probability that a person selected at random from the survey group is male or has a two-handed backhand swing? So male, that's everything in this circle, or has a two-handed backhand swing. So that includes this right here too, because it didn't verify that male or male with a two-handed backhand swing. So that is 341 plus 80 plus 176 all over the total 758. And that's exactly what I have here. 421 plus 256 is minus 80. Oh, I see that. I've done something incorrect on here. I believe I subtract the 80 from the male with the two-handed backhand swing. Oh, because it doesn't say, okay, I get it. So anyway, I think that may be incorrect. I'm going to go back and look at it. What is the probability the person selected at random from the survey group does not have a two-handed backhand swing, given that the person is male? Or probability no two-handed backhand and male. That is this section right here, 341. And I believe that is the answer. 341 do not have a two-handed backhand swing, so 341 over 421, or about 81%. Notice that I only looked at the people that are male. I didn't look at this section over here because it says given that the person is male. So I'm not looking at anything to do with the female. I'm just looking at the male section. So the answer is 341 over 421, which is 81%. All right. So I'm going to launch you with this little Venn diagram. It's kind of funny. So the three sections are bank robbers, DJs, and preachers, right? Bank robbers and DJs both say, everybody on the floor. Bank robbers and preachers say, give me your money. DJs and preachers say, are you with me? And they all say, put your hands up. Anyway, have a great day. Be blessed. Be a blessing. Don't forget that you got a lesson in the Google Classroom. Take care of that as soon as possible. Faster you get it done, less work you have to do in the long run. All right. Have a great day.